Hi, I'm Chad Lawson. This is beginning to look a lot like Christmas, and you're watching Verbose mode. Hi, I'm Chad Lawson. Today's episode of Verbose mode is talking a little bit about the Christmas items that we have going on upstairs for our lights. I wanted to start off by talking a little bit about the backstory for this particular experience, if you will. A number of years ago, we adopted a small beagle that we joke is part cat. She did all the typical things that a cat does when it comes to Christmas trees. She destroyed it. For years, we had your typical plastic tree, all pre-lit, assemble it, connect everything together, and you've got instant Christmas. And we'd decorated and enjoyed it. But when we got Teeny, our little terror in a fur form, we switched up our approach. Instead, what we started using was a pre-lit garland strand that went across the fireplace hearth. And it was just the lights were on, and that was it. And it was fine. And what we would do instead of decorations, the typical ornaments, is as we received our various Christmas cards from friends and family around the world, we would punch a hole in it, put a hook onto it, a little bit of string to hold it all together, and then hang that on the garland. And our garland became our Christmas tree, and our ornaments were all of our the messages of love from our friends. And that worked really well because Teeny didn't bother it, and so we didn't have any problems. But this year I decided I've been doing so much with different Neopixel type lights and controllable RGB red, green, blue lights that I wanted to make my own. And I got the go ahead. And also, I wanted to do something a little different than the plastic light strand of garland. We were already using I'm hesitant to call it a live wreath because by the time it's in wreath form, it's not alive anymore. But an actual pine wreath. This year I wanted to use a pine garland as well. So I went out to our local flower and garden shop and bought the garland. And I also included in some additional components. The build itself is actually pretty simple. I have our power supply. I have an Altoids mint tin. I just It's become kind of one of my go-to for quick enclosures for a project. And in this case, I've already taken the tin snips and cut out a panel on each end. I have this. This is a 3D printed raft for using a Arduino Uno in a mint tin. And as you can see, this thing just kind of slides into place, holds pretty firm. This is a little bit of a hack job with the tin over here, so it kind of pushes things around. But the centerpiece of our project is pretty much everywhere you look, we've got an Arduino Uno. And this, like I said, was designed to be able to just fit right into this. So by using the raft, the mint tin, and the Uno, I now have a microcontroller in a box. And I have to show off. I couldn't resist the joke. This particular one is wintergreen Altoids. Figure wintergreen for the whole thing. All right, not that great of a joke. The other component of this is these strands of Neopixels. These, I've got the link on the show notes as to where you can purchase these. There's a number of different locations, but I'll show you where I ended up picking these up. These are using chips in them called WS8211. And I had to find that out through the data sheet. But they have these two strands of wire. This is for power and ground, and then this is for data and ground. And each one of these chains has two ends, so that you can connect the output of one into the input of another. Just simply splice the power and ground lines together with the other end, and you can keep making these chains go on and on, as long as you have enough power and as long as there's enough memory in your microcontroller to handle it. I didn't want to have this all undone, but you can see here roughly how far we have in between each of our pixels. And these are jokingly sometimes called bullet pixels. The main thing, and one of the hardest challenges I had, was figuring out which side was in, which side was out. So after setting up my test code, I simply plugged each end in and figured out which one actually worked. Then I found out, looking at the data sheet, I don't think this is coming in on the camera too well. I'm going to try moving a little closer. There's a little arrow on each one of these, and that represents input. So if I had actually looked at that and found that, I would have known, and this would have gone easier. Now, I would normally then just plug the DC power in, hook up all of my connectors into the Arduino, close it all up, and be done. But like I said, for me, the interesting part about this particular project isn't the hardware build. The hardware build's pretty simple. It's an Arduino and a Mint tin. But for me, I found finding all the different ways to code these lights was actually the more interesting part. So I'm going to switch over to the computer, and we're going to take a look at the code. This is just using Adafruit's Neopixel library. I define what data pin, and it does have to be one of the pulse width modulation pins on your Arduino to be able to do this. And then how many pixels. Now these strands, all right, so the hardware wasn't exactly easy. The strands themselves come in sets of 50. My code shows that there's only 49 in my given strand. And the reason for that is because when I was playing around with some of this and getting a little, before I found that nice little arrow, I don't know how, but I managed to kill, I thought I killed the entire strand. I could only control one of the pixels. Once I cut that pixel off and then respliced wires in, I could control the entire strand. So I did kill one, so where this should be 50, we've only got 49. Here on line 6 is where I initialize my Neopixel strip, defining what pin and how many Neopixels. The actual original code has the header in it. You have to define whether the input is RGB or GRB are the two most common. In other words, when you send in colors, are you sending in the red value, then the green, then the blue, or are you sending in the green value, then the red, then the blue? I have found in both in my experiences with different types of Neopixels, I just a matter of tinkering around, sending in sample code and figuring out which comes out first. And then determining does it operate at 400 or 800 kilohertz are the two main values. In this case, it was just a little experimentation and finding out it was 400. Here I'm defining what I want my maximum brightness to be. The Neopixels, by default, when you send in the maximum value, 255, an 8-bit value, you're sending in a total of 24 bits. 8 bits, 0 to 255 for the red, for the green, and for the blue, or green, red, blue, depending. And the maximum value can then be 255. And when you send a value of all red at 255, man, can 49 pixels light up a room. And seeing as this is supposed to be something that's a little more subtle, I just took this line here for the set brightness here at line 15, which sets the maximum brightness it can be. So when I go ahead and send in I want 255, it cuts it back to whatever my maximum brightness is, and it does it proportionally against all three values, and I absolutely love that. So when I was playing with this, I initially had the brightness set at maximum at 255. Like I said, that completely lit up the room to an unacceptable level. You could pretty much, if you really wanted, we're not that far from General Mitchell Airport. I'm sure planes could have seen our lights from space at that point. Yes, I know they're not in space, but anyway. So I cut it back initially to 128. That was still kind of a little too bright. 64 is doing a pretty good job for now, so we're leaving it at that. And I have defined a pause of number of cycles in between, and when you see the code, you'll understand. But here's where I'm defining, this is using this integer 32, which means it's storing 32 bits, because like I said, there's 8 bits for the red, for the green, for the blue. So I needed to be able to have a value that stores everything I need, and I'm just borrowing this code straight from the Neopixel library. And I've defined a total of 4 colors. The first one being red, 25500, green, 02550. We'll jump over here to, oh, look at this. I've got something in here twice at the moment. We'll get rid of this extra one. I didn't clear that before I came in here. And the middle one then being my gold. So a lot of red, a little bit of green, and there gets my nice gold color. Then I'm defining an integer string, an array of integers, and I'm defining it at the same number as the number of pixels I have. And this is where the things start to get a little interesting for this particular version. The first version of code, the code that I had, was pretty straightforward. At the very beginning, when you first go into setup, and if you're not familiar with Arduino code, there's the two main functions, setup and loop. When you first power on an Arduino after it gets through the bootloader, it runs everything in the setup. That's all of your initialization and getting ready. After that, it moves into loop, and for as long as it has power, it starts at the top of loop, goes down to the end, and continues this over and over. So looking at in my initial version of it, my setup just simply said, all right, go through all, in this case, 49 pixels, pick one of those random 4 colors and set it. And then in the loop, it would just every single time through the loop, it would pick a random pixel along the strand, pick a random one of those 4 colors and set it to that. And it worked fine. The reason I didn't like it, it was great I'm throwing this together for a couple weeks before Christmas. But watching it for a little while started to drive me crazy because we'd have huge clusters of a lot of red here, a lot of gold here, a lot of blue here, and then we'd have just little clusters, and I didn't like it. So I wanted to be able to come up with a way to keep track of what each of those pixels were, and then on every single loop through, when you pick it, choose an appropriate alternate color, one that wasn't the same one. So in other words, if it was already blue, it didn't repick blue, and it wouldn't pick the same color as one of its neighbors. So I'm going to go through the code, but I've got my dry erase board here to kind of help illustrate what I came up with. This is either to some of you, this is going to be genius, and to others, you're going to be writing into the comments or sending me messages on Twitter that I could have done this a lot easier and a lot better. And if that's the case, please do. I would love to continue learning from this project. It was something initially I just threw together to have some fun, but I'd love to be able to learn a better way of doing it. But this is what I came up with. So during my setup, I initialized my Neopixel strip. I set the brightness to that value I talked about, and because I'm a debugging junkie, I have serial output coming through here. So on the first pass, I'm creating a simple integer of y to keep track of a value to pull from that array, and then I'm just using x to iterate through all the Neopixels, and I'm taking then that it should set Neopixel X, in this case 0, 1, 2, etc., and use colors of Y mod 4. If you're not familiar with modulo arithmetic, it's using the remainder of division. So if I say 5 mod 4, I can take 4 out of that 5 and have 1 remaining. So 1 is the output of modulo, mod, I'm going to be using from now on. So each time through, as the X value is counting 0, 1, 2, 3, 4, 5, 6, 7, 8. I'm just dividing by 4 and taking the remainder and taking that value from my array of colors. So it becomes 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3 all the way through. And from there, I'm just setting my string so that I have that memory. And the reason I'm doing it through this array as opposed to where all I'm keeping is in that string the 0, 1, 2, or 3. I'm not keeping specifically red, green, gold because that's 24 bits for each of those colors. And instead of storing 24 bits over and again, I just need a simple array to tell me 0, 1, 2, or 3. Which one of those 4 colors is it? And that's what I'm using instead of storing the entire color value. And then I show that. I send the command show so that whatever those pixels chose as part of the startup, they become visible. 0, 1, 2, 3. So just over and over again, it's red, green, gold, blue, red, green, gold, blue. So the first loop through, that's all we've got over and over again. Then when we come into the actual loop, I pick a random pixel, and I'm starting at 1 and ending at my number of pixels minus 1. Originally, when I started building this, I had problems where the program would pause, and I thought it was because it would hit either 0 or the last one, and the next block of code then says, okay, what value is the current one the next one, and the previous one. And if it was at either end, I didn't know if I was hitting some sort of memory block that was invalid and causing the entire code to crash. So I confined it in so I don't have to do any goofy additional code to say, if you happen to pick number 0, only don't worry about what previous was, and if you hit the last one, number 49, don't worry about what the next one is. I didn't want to do any of that, so whatever numbers 0 and 49 get set to, those stay for the entire run as long as the strip is on. I guess I could put in some additional code, but I'm not going to bother for now. And then I'm running this function called choose1 and passing in that value. Once it gives back to me a value, and I set it to that color array of 0, 1, 2, or 3. So once it pulls that out, it gets, is that red, is that green, gold, and so on. It then displays the entire pixel string and updates my array. So the first time through it was just 0, 1, 2, 3, 0, 1, 2, 3. And then as those values start to change, the value gets, the array that keeps track of that gets updated. I have my delay, and there's a few people probably watching right now, one person in particular, who is laughing hysterically seeing me use a delay in a code. It's a perfectly valid thing in the right circumstances, but I have harped on a number of people to not use delay, because anytime you're using a delay in a code, nothing else can be happening in terms of input. So if your code is expecting a button to be pushed, a rotary encoder to be turned, when you use delay, the code isn't looking for that. So it can cause some timing issues. So I absolutely never use delay, except for this project. So laugh all you like. You know who you are. My choose1 function I mentioned earlier, it takes in whichever random position I picked, and then I set up an array of possible values that can go in here. It finds out, it then chooses a position within that array. I then find out what the value is at the current position, the previous condition, and the next condition. And this little block of code then, and I'm about to just switch to the dry erase board to make this easier, but it determines, okay, it then loops through for each possible value, 0, 1, 2, or 3, and says, okay, is 0 the current one, the previous one, or the next one? If not, add it to the list of possible candidates. If it is, skip on to the next one. And then it returns an array, or it stores this into an array of possible candidates, colors that aren't immediately adjacent or the current one, to go back and then pick a random one of those. So tell you what, since this is becoming a little complicated, let's, instead of looking at the code, I think this would make more sense. This is how I found the answer to this, was by dry erase boarding it out. I was going to say whiteboarding it, which would have made way more sense. Okay, so here I've got my dry erase board. So the first time through the code, during the setup routine, that array of values is just simply 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, all the way through my entire string. So let's say that when it gets into the loop for that first time, it says, all right, let's choose this one. So my choose function, and I'm going to pop back to it so we can reference it for a moment, says, okay, get the value of the current one, the previous, and the next. Okay, so the current is 0, the previous is 3, the next is 1. And then back here in my code, it says, all right, so starting with 0 and going through 3, find out, create an array of all the ones that isn't one of those 3. And so on the very first pass, we're not going to get anything terribly exciting. My list of candidates can it be a 0? No, because that's my current. Can it be a 1? No, because that's my next. Can it be a 2? Absolutely. Could it be a 3? No, because that's my previous. So the only one that it can change to on the first time, so if it picks randomly between 2 and, well, that's it, then it changes this to 2, and we move on. And you can see that for a lot of these, on the first pass through, it's going to be the same type of thing. Let's take my 3, for example, here, it's going to know that my previous and next are 0 and 2. So can it be a 0? No. Can it be a 1? Sure. Could it be a 2? No. Could it be a 3? No. So it has to pick randomly between 1 and nothing to be 1. So this gets changed to 1. After that is where other possibilities start to come in. Let's say later we come in here and we pick this value. So I store my previous and my next, and I go through my loop. Could it be a 0? Sure. Could it be a 1? No. Could it be a 2? No. Could it be a 3? So my 2 possible candidates are 0 or 3. Pick a random one of those 2. In this case, let's say 0. And so at no point am I ever changing a pixel to what it was or to what one of its neighbors are, but there are going to be places within the strand where an entire color is missing. Like throughout here, we have no 3. You have to go this far back to get to a 3. And there are going to be times where a color is less frequent, but you're not going to anymore have those giant clusters of reds or greens or golds. Instead, we're going to be constantly going through and picking only of the different candidates. So for like most of those first loops through, it's simply flipping to the opposite. If it's a 0, it becomes a 2. If it's a 1, it becomes a 3, and then opposite for the other 2. So like I said, it's not mind-boggling code by any stretch of the imagination, but I needed to come up with a way to make sure that I didn't have those giant clusters, because once I got the brightness and no more planes attempting to land at my house, I wanted to find a way to make it a little more interesting, that I could actually see what was going on and control to make sure I didn't have those giant clusters. So I hope that this has been something interesting episode for you. I wanted to put up the nice little card here. If you have any questions, please, by all means, come and follow us on Twitter at Verbose Mode TV. If you have any questions about this particular episode, any follow-up, if you have better code, let me know. You can find us, again, on Twitter at Verbose Mode TV, on our website, verbosemode.tv. Through YouTube, our channel is Verbose Mode TV. I think you see a trend here. So, hopefully we'll see you soon for future episodes. And in the meantime, happy holidays, whichever one you happen to be celebrating. Thank you.